Good morning. Myself T. Shivkumar, a lecturer in Electrical and Electronics Department, Government Polytechnic Raichur, from Department of Collegiate and Technical Education, Bangalore. I welcome all of you for this Power Electronics lab session. Today we are going to conduct an experiment number 2, that is VI characteristics of SCR. The aim of the experiment is to conduct an experiment to plot the forward biased VI characteristics of SCR for different gate currents. Before we proceed to instructions to conduct an experiment, let us go through the construction and working of SCR and also the VI characteristics of SCR. SCR is a 4-layer, 3-terminal, 3-junction PN semiconductor device. It has 3 terminals, namely the anode, cathode, and third one is gate, which is connected to inner P layer. This is the symbol used to represent the SCR. The SCR can conduct in only one direction, that is from anode to cathode, like your diode. It allows the large current flows from anode to cathode when it is triggered by a gate signal applied between gate and cathode. Now let us see the turn-on methods of SCR. SCR can be turned on by 2 methods. First one is it can be turned on by applying anode voltage more than the breaker voltage with gate terminal is open. The another way to turn on is the SCR can be turned on at less than breaker voltage by applying a very small positive voltage between gate and cathode. Now these are the 2 methods to turn on the SCR. Now let us see the turn off methods of SCR. The SCR can be turned off by reducing the anode current to 0 or below the level of holding current. It can also be turned off by applying a reverse voltage between anode and cathode terminals. Next, we shall see the turn on methods, the operation of SCR. It has 3 modes of operation. The first one is the forward blocking mode. In this case, the SCR, the anode is connected to positive and cathode is connected to negative, and with gate terminal is open. Now the SCR is said to be forward biased. In this case, the junction J1 and J3 are forward biased and the junction J2 is reverse biased. And there is a depletion layer across J2, due to which the SCR offers very high resistance and very small amount of current will flow through from anode to a cathode. Now the SCR is said to be in forward blocking mode and it acts as open switch. Next we have the reverse blocking mode. In this case, the anode terminal is connected to negative and cathode is connected to positive with gate terminal is open. Under this condition, junction J1 and J3 are reverse biased and junction J2 is forward biased. Only the reverse leakage current will flow through the device. Due to the depletion layer across J1 and J3, SCR offers very high resistance, so very small current will flow through the device. Now the device is said to be in reverse blocking mode. In this mode, the SCR is again acts as the open switch. Now the third one is forward conduction mode. In this case, SCR is forward biased. That means the anode is connected to positive and cathode is connected to negative. The SCR can be turned on by increasing the supply voltage to more than breakover voltage of SCR, or by applying a small gate voltage between gate and cathode. The SCR is made to turn on. When the SCR is turned on, the reverse bias junction will break down and the device offers very small resistance between an anode and cathode, and the anode current flows through the device rises very quickly, and this current can be limited by external load. Now the device is said to be in forward conduction mode. Next, we have the VI characteristics of SCR. Now this is the plot between voltage across anode and cathode and anode current. Now the voltage across SCR is taken along x-axis and anode current is taken along y-axis. When with gate current is 0, when the voltage across anode and cathode is increased in forward direction, the current flows through the device is very small. You can see this curve here. It is a flat curve. It is almost lying on the x-axis. So very small amount of current will be flowing through the device. So when the supply voltage is equal to breakover voltage, there is sudden drop in the voltage. You can see here dotted line. The voltage will be sudden drops to minimum value and current will shoot up. That means the current will increases rapidly. Now the device is said to be in forward conduction mode. As I said earlier, it can also be turned on at voltage less than the forward voltage. Here you can see this is the gate current 1. It is turned on the voltage at less than VBO, that is breakover voltage, and at for IZ2 the breakdown voltage is still it is reduced, and for IZ3 again the breakdown voltage is reduced. Here the value of IZ3 is more than IZ2 and which is more than IZ1. As the gate current is increases, the breaker voltage goes on decreases. As you can see here, it is less than the VBO. It is the breaker voltage without the gate voltage. Next we shall see the experiment on VI characteristics. Now these are the equipments required to conduct the experiment. So we need regulated power supply. In this experiment we are using the SCR TYN 604, and these are the other components required: the DC voltmeter, ammeter, which are used to measure the voltage across SCR and anode current, as well as the gate current. Now this is the circuit diagram. Now here you can see the supply voltage is connected between the anode and cathode through ammeter. This is used to measure the anode current. Now this is the load resistance to limit the load current. Now this is the voltmeter, 0 to 100 volts. which is connected across anode and cathode to measure the voltage across anode and cathode. Now this is the ammeter to measure the gate current. Now this one is the gate voltage applied between the gate and cathode. Next, the procedure. Here connections are made as per the circuit diagram. Then switch on the power supply for both power supplies. Then keep the gate current say 2 or 3 milliamps and increase this supply voltage in steps of 5 volt. Then for every 5 volt step you can note down the reading of voltmeter as well as anode current. Go on increase the voltage till SCR is turned on, which is indicated by sudden drop in the voltage of voltmeter reading and sudden increase in the anode current. You can note down the voltage at which the SCR is turned on, which is the breakover voltage at that particular gate current, and that is the current, latching current that flows through the anode. Then once it is turned on, the gate will loses its control. Then even if you increase the voltage, then there is increase in the current. You can note down also, you can note down these readings also. Then to measure the holding current, now you have to switch off the gate supply and reduce the supply voltage till there is a rise in the voltage. So when the device is in conducting, the voltmeter will show very small value, that is around 1 volt. Then as you reduce the voltage, there is a slightly increase in the voltmeter reading. That means here SCR is turned off. Then there is sudden drop in the anode current that gives the holding current. You can note down this holding current and the voltage across SCR. Then finally you can make the supply voltage 0. Then you can repeat this experiment for different value of gate current. Then you can note down the reading accordingly. Then you can draw this is the tabular column. Here you can take down the gate current and here you can note down the voltage in steps of 5. Then you can note down the anode current. Now you can also note down the voltage across SCR when it is turned on, and you can also note down the current when the SCR is in conducting state. Then you can also note down the holding current. You can repeat this experiment for different value of gate current. Then using this current readings, you can plot the graph. Then your graph will looks almost like your nature of a graph. Okay. Now this is regarding the instructions to conduct an experiment. Now let us move to the lab to conduct an experiment on SCR. From this experiment we can conclude that SCR can be turned on by applying very small positive gate voltage. SCR can be turned on at a different voltage by changing the gate current, as I explained while explaining the characteristics. As the gate current is increases, the breakover voltage is also decreases. That you can confirm with the readings. Now let us move to the experiment table to conduct any experiment. Welcome back to experiment. Now we are on the experiment table. I have made the connection for the circuit diagram as per the circuit diagram on the breadboard. Now this is the power supply. I am using it for anode to cathode, the main power supply. I am using 0 to 70 volt, but in the diagram it is shown 0 to 100 volt, but I can get 0 to 70 volt here. Now this is the power supply for gate 0 to 30 volt. Now this is the multimeter I am using here to measure the anode current, because we need to change the range here. First I can get here 0 to 10 milliamps range. Now this is a voltmeter to measure the voltage across SCR. Now this is the milliammeter used to measure the gate current. Now this is the load resistance, 120 ohm 5 watt resistor I am using here. Now this is the SCR TYN 604. Now this is the gate resistance 1 kilo ohm. Now let us see the connections here. Now the positive terminal of the main power supply is connected to ammeter, the positive terminal of the ammeter. The negative terminal to a load, you can see here the load resistance. Now load resistance, then load resistance to anode. The middle terminal is anode here. Then cathode is connected to the return path. Now this line is the return path. Now this line is connected to the negative terminal of the power supply. You can see here the black terminal. Now this is about the main circuit. Now regarding the control circuit, now this is the positive terminal of the power supply that is connected to positive terminal of the milliammeter. Then the negative terminal to resistance, then resistance to gate here. Now the cathode is already connected here. Now this is connected back to the negative terminal of the power supply. Now this is about the connection here. Now let us start with the reading here. Okay. Now switch on the power supply, means power supply as well as gate power supply. Now as per our diagram, as per the procedure, now we will set the gate current to say 2.5 or 2.6 here. Okay. Now I will apply the main voltage here. Now you can see the voltmeter reading here. Now it is showing the reading. Now just now I apply the 5 volt here. Now the voltmeter is showing, it means it is blocking. So the voltmeter is showing, now I applied 20 volt, the meter is showing 20 volt here, but I connected to 0 to 100 volt range. Now you need to double the value, because the measuring is here, it is showing 0 to 50, that means the next one is 100. So you have to double the reading. So applied voltage is 20 volt. Now you can see here the current, the anode current, now it is in the range of 0 to 10 milliamps. It is less than 1 milliamp. It is around 0.3 milliamps. Now okay. Now first we apply the voltage in 5 volt step, and for each step we will take the reading. Say now I applied the 5 volt. At 5 volt the current is 0.1 milliamps here, very small current. Then I will increase the voltage, say 10 volts. So for 10 volts the current is 0.1 milliamps again. Then I apply the 15 volt and current is 0.2 milliamps. Like that for every 5 volt step you can go on taking the readings here. Now I am increasing the voltage, and for every 5 volt step I am taking the value here. So I will increase this voltage to some value, say 60 volt. I will take, now I want to turn on the SCR at 60 volt, so that as I kept this value at 60 volt. Of voltage, the turn on of SCR is noted by sudden decrease in the voltmeter. Now the SCR is turned on. Now current is also shoot up. Now the current is showing, it is almost 0. It is around 1 volt. Now this is the conduction voltage. Now the current is maximum here. Now I change the reading. Now it is showing 290 milliamps. Okay. Now this is the current through the SCR after turning on. Now this is the voltage. It is around 1 volt. It is now turning on. Now to find out the holding current, you just reduce the gate current to 0, then can reduce the voltage. Now I am reducing the voltage, but still voltmeter showing 0. That means it is still in conducting state. Now to get back the holding current, now you can see here, the current is still, it is more. Now it means still, that means the SCR is in conducting a state. Now you can see here still voltage is 0. Now the blocking state is indicated by slight increase in the voltage. That you can see here, current is also decreasing and voltmeter is showing 0. Then now you can see here the voltage, I'm reducing. Okay, now you can see here there is rise in the voltage. That is, the device is returned back to the blocking volt, and current is dropped from 0.5 milliamps. Now it is now the device is in blocking state. It is almost showing 1.1 milliamps. Now the holding current is 5 milliamps. Now all these readings are I noted. So here like this you can noted the readings here. So for 5 volt 0.1 milliamps, 10 volt 0.1, like that I have taken here up to 60. The current is jumped from 0.8 to 290 milliamps. Just I will write the value here. Now this is the breakover voltage 60 volt. Now current is 2.8 milliamps. Gate current is 2.8 milliamps. At 2.8 milliamps, my SCR is turned on at 60 volt. At the time of turning on, it is 0.8. After that, it will be increased to 290. That is conduction current when the SCR is turned on. Now this is the voltage when the SCR is in on state. So when the SCR is in on state, the voltage is around 0.7 to 1 volt. Now this one is the holding current. Now like this, you can reconduct the experiment for different value of gate current. Then you can tabulate the values in the next column here. After that, by using these readings, you can plot the graph by taking anode current and voltage across SCR. After that, after drawing the curve, your plot will be almost look like, because we are just drawing only the forward characteristics. So your drawn characteristics will be almost looks like this. Then you can compare your graph with this, the nature of a graph. Okay. Thank you.